Cool. So it seems like we have a pretty knowledgeable group of individuals today. I'd say average score of knowledge on blockchain was about like a 4 or a 5. Let me show this. So this presentation right here may be a little bit too introductory for a couple of you, but we wanted to just make sure that everyone's on the same page about what this technology is. So real brief, we're just going to run through. I told you guys a little bit about the club, but here's a little bit more. So started last year, 2018. We had about 20 students from various backgrounds: computer science, design, business, graduate programs, and more. That right there is Erica. She was our president last year. Abe, VP, Sam, our graduate student, and Ari, our co-president alongside Erica. I'm not in this photo because I took it. But yeah, so we were started last year. We're part of the College of Engineering. Our advisor is Zachary Peterson. But yeah, that's another big reason why we wanted to focus more on development this year, is because we're rooted in the College of Engineering. So it makes a lot of sense to actually be engineering these applications. And so what do we do? I sort of touched on this a little bit, but education, research, and development. First and foremost, education, though. Make sure everyone understands what the technology is. Research, so diving a little bit deeper into it. We've had some students write some research papers before. We've had some students make some deep dive presentations into select topics. And we've also had students, outside the club, but do some sort of consulting stuff for various tech companies in the space of blockchain. We hope to do some of this internally this year. And then we for sure will be doing development. Like I said, starting next week, we'll be working on the voting application. Last year, we were able to do a little bit. We were able to get about, for sure, at least half the members to launch their own ERC-721 token, which was super cool. Dan will be walking you through a little bit of that, just sort of showing you the interaction with the MetaMask plugin later on today. But you'll be able to launch your own ERC-720 token, 21 token, or we'll be also making decentralized applications, which we'll talk about in a little bit. But yeah, so what even is blockchain? Well, in layman's terms, it's a continuously updated ledger of who owns what. So in the traditional world, whenever you make some change to a database, there's almost always some human fact checker that is sort of ensuring that whatever is being added is legitimate, whether it be Wikipedia or Chase Bank. There's always sort of that intermediary that's validating these transactions, these updates to a database that are taking place. But with blockchain, it's kind of like having that database with a network of computers, and it's sort of like having your Facebook feed like constantly downloading whatever's up to date and current. It's always continuously updating the current state of the network. And so how things used to be and how things currently are is vast amounts of information are controlled and managed by centralized institutions. So these are companies like Facebook, Tinder, Amazon. Tinder's actually on Amazon, and these are people who we sort of trust to act honestly. So you could think back to like the 2008 financial crisis with like Lehman, for example. Their clients trusted them that their books were legitimate and that they weren't going to go bankrupt, but the lack of transparency is what made the opportunity for a failure like that to happen, along with the combination of other things. But technology now is really enabling a shift away from these centralized repositories of information to more decentralized, robust, fault-tolerant networks. And it's a lot of jumbled words right there, but we'll dive into a little bit more what that looks like right here. So, and here's just a brief visual representation. So it's distributed and decentralized. Distributed networks are nothing new, right? Or decentralized networks are nothing new. Blockchain is a type of decentralized network, which we'll get into a bit. But what this really allows is, first and foremost, immutable data. So this is one of the key aspects of blockchain, is that what you put in is permanent. You cannot alter the data once it's in the blockchain. And we have an activity to dive into this a little bit more, but the way that this takes place is through public and private key cryptography and consensus mechanisms. So it's really rooting trust in mathematical proofs, per se, instead of human trust. And later on, we'll talk about the ability to basically program money with Ethereum smart contracts. So you can sort of think of like writing if-then statements, but with actual money in a very easy And democratic ability is using decentralized autonomous organizations. So linking these things together, linking the smart contracts together, where one smart contract triggers another, to create an entire company out of it. So you can imagine what that looks like. And we'll dive into a little bit more examples of each of these later on. But so sort of setting the scene. So back in, we'll call this like 2000s to like 2016 was really the foundation. This is when people were making deep web drug purchases with Bitcoin. These are like actual crazy people. People posting a forum saying that they'd buy a pizza for like 20,000 Bitcoin. And this is really the inception of this whole thing. And so really no one understood what it was, just like how whenever the internet got started, everyone thought it was a fad. And then the hype cycle happened, just like with the internet. And it got to a point to where, I'm sure you guys know what ICOs are, initial coin offerings. So you could sell off this ERC20 token for real US dollars and in exchange really give nothing back. These people, it's basically like an initial public offering of the company, but with tokens. And no regulation from the SEC during that time. And so lots of scams were taking place. Paris Hilton was marketing an ICO. That's a red flag of some hype cycle taking place. Bitcoin to 20,000, lots of skepticism. But now, now that everything's starting to die down, now that 95% of blockchain startups have failed, the dust has settled, and we're in the stage of real impact. We're in the stage where nations are starting to implement cryptocurrencies to combat corruption. We're in the stage where we have peer-to-peer electricity systems that are potentially disrupting big companies like PG&E. And we're in the stage where real disruption is finally taking place with these technologies. So what does this look like? So here's a few brief examples. And by the way, we'll send out these slides to you guys so you can go through later. But it's interactive, so you can click on these and it'll take you to their websites. But Augur is, show of hands actually real quick. Who here knows Augur? None. Really? Wow. Okay. So Augur is an application, a decentralized application for making prediction markets. So let's say if I wanted to host a bet that the Democrats are going to win the 2020 election, let's say, I can put that bet on the Augur network and people can start betting against each other. And I would be the host of that bet. And we'll have a deep dive presentation on each of these later, so these are just sort of showing you guys what can be done. But perfect example of programmable money to where if this happens, then that. Doc AI is a startup that's connecting consenting participants with medical researchers that are using machine learning algorithms on these patients' data. And so what it does is it ensures that if you give us this data, you know exactly where it's going, and it ensures financial compensation for whatever you give them. Fluidity, this is really cool. Anyone here interested in the financial side of blockchain? Cool. This is a really big thing. Tokenization. So Fluidity, what they do is asset tokenization. So you can imagine, let's say if you got a $20 million penthouse in New York, or that's the example that they do. So they've actually tokenized like very expensive penthouses. But I think where this starts to really become impactful is you can imagine like big civic centers. So like a huge event complex to where there's various like parts of the building that you maybe sell to like, you'd maybe sell like the first floor to some startup and the top 3 floors to like some big Fortune 500 company. Or even maybe you just sell individual offices, and so you can tokenize the entire building and really tap into a whole new pool of capital that's global. And that's the big part there, is that it's global with far less friction. And so these applications, and then last one, Power Ledger, so peer-to-peer energy distribution. We'll have another deep dive video on that later, but these are really just touching the surface on what can be done. There's a bunch of other startups that we'll talk about, but just sort of wanted to let you guys know a few of them. And just like that, that's how easy it is. That's how easy blockchain is to understand. It's just like that. No, I'm just kidding. But there's a lot more to learn, but that's sort of just like a gist of what it's about. And then here's to get you guys a little bit excited about it. So it's had some pretty good sustained growth going forward. Obviously, it had a big spike in 2018 with the bubble during the winter season, but it's had very good sustained growth. It's like over $2 billion in global VC investments this last year already, and it's not even done yet. And so, yeah, get involved. Let's kickstart your career into the new age of computing, finance, and the internet. Let's shape the future. We have opportunities with doing research, development, design, just entrepreneurs, educators, managers, planners, planners, advisors, a bunch of different things. Whatever you're interested in, we most likely have an opportunity for you. And here's just a brief outline, not a big deal though. We'll skim through this stuff really quick. Yeah, so let's dive into a little bit more about what blockchain is. So here are some problems with the current world. So assets, like money, are really difficult to transact and move around. Here in America, it's not that big of a deal. For example, I could send Sullivan $1,000 on Venmo right now, and you could have it in your account. And if you have a Venmo card, you could go spend that money wherever you want. But if you don't have a Venmo card, it gets a little bit trickier. You have to transfer it to your bank account. So I can send you the money, but the funds won't technically settle right away. And that's where it gets tricky, is that the funds won't settle as quickly as various things. But so here in America, our financial system's fine. Like how I said, for the most part, we trust Chase Bank. Like I don't think Chase Bank is going to go bankrupt anytime soon. But whenever you start to expand your horizon globally, this really becomes a big issue. So if I wanted to send money to China right now, for example, there's a massive fee that Chase is going to take. And it's going to take a lot of time as well for the money to get there. And then also, if you dive a little bit deeper, sort of what we were talking about with tokenization, if you look at other types of assets besides money, there are just antiquated regulatory systems and antiquated technology that is holding back the possibilities to be able to liquidate these assets. And fun fact on that part, currently, I forgot the company, it's later on, but they're approximately 20% of global transactions from US citizens use cryptocurrencies, which is rad. 25% of global transactions, people are already using crypto. So that right there is big. And then data. So again, data is controlled by central authorities and silos that we don't have control over, so we don't know what they're doing with our data. We assume Tinder's not analyzing all the people we're swiping left and right on to understand what kind of people we like, to make like, I don't know, maybe they'll advertise like sex robot dolls to us one day, you know? Like, not cool, man. And then intermediaries, again, so unnecessary, integrated into systems and applications. These trusted people in between us while we're placing our bets. Let's get rid of them and just put a network computer. It's an antiquated system. Like, I know I got to talk to a bunch of you guys at Club Rush, but like why don't you guys start shouting it out? Like, what are some issues with holding the 2020 election on the blockchain? Or not on the, what are some issues with holding it on a website? Like, why can't we make a web? Why can't the U.S. government make a website?
Security reasons.
What security reasons?
Identity theft.
Identity theft.
Voter fraud.
Yeah. Bots.
What was it?
Bots.
Bots.
Yeah.
What about them being able to just change the code entirely? Change it so that maybe if you're in a certain region, your vote only counts for half a vote. Or maybe your vote doesn't count at all. Or maybe they go into the database afterwards and change your votes entirely. So there's a lot that can be done. I'm sorry, what was that?
Coercion's a huge one too. That should be mentioned. If you're not in the voting booth, they don't know that someone's not standing over your shoulder and beat the shit out of you for voting for the wrong guy.
Yeah. But yeah, so I think that's a really good example for highlighting what blockchain is, what it can be. Is looking at that last example. Why not hold the 2020 election on the website? So we're going to dive into these problems and explain how blockchain is solving. So today, ledgers, again, sort of already went over this, but centralized repositories of information, we trust them to act honestly. But in the future, we're going to be moving towards a more decentralized, more robust, fault-tolerant networks, blockchain. So real quick, do you guys understand what a ledger is? Whenever I say distributed ledgers or centralized ledgers, do you guys know what that is? Show of hands. All right, right on. So I'll actually go through this pretty quick then. But a ledger is just a data source that tracks who owns what. And there's some benefits with having this be central. So in blockchain isn't a hammer nail, so it was very, and I know we focused a lot on this last year, but really hammering in on, not really intended, but hammering in on the good and bad use cases of blockchain. It is not hammer nail. It has its select use cases that it excels at, and then there's a lot that we should just leave to centralized networks to handle. Some stuff that central authority is good for is data integrity. By restricting the access to the ledger, you know who has the ability to agitate and change the data on the network. Knowing its location, it's very accessible to yourself, and it has pretty fast retrieval. at least compared to what we're going to be diving into. Our networks have improved very well, and they're really efficient for these reasons. But there's also some problems. We've already talked about these, but data ownership, data hampering, and you're putting your trust in the people. So whenever we're thinking about blockchain and sort of how we can take this system and distribute it amongst a network of computers, there's some things that have to take place in order for it to be a database and a network. For it to be a database, the updates all need to be atomic, so they all need to happen or none of them happen. So all of the updates to the ledger need to go through or none of them go through. They can't be in lingo somewhere. It needs to be durable, so that it needs to have no chance of being reverted. So if I were to upload data to the blockchain, I wouldn't be able to go back and change some of the information from 2 months ago. And it needs to be consistent, so you need to be able to modify this data in a reliable, dependent way. And so looking forward, away from central ledgers to distributed ledgers, data integrity, again, is rooted in the trust of public and private key cryptography. I guess, real quick, show of hands. Do you guys understand what I talk about when I say cryptography? Okay, so you guys know like what hash functions are and whatnot? Okay, cool. And so blockchain is just one type of distributed ledger. It's important to know that. Again, this technology has existed before. Other parts of various blockchain technologies have existed before too, like proof of work, which we'll talk about in a bit. But it's really the combination of these ideas in the self-sustaining network and database. So diving into it, consensus mechanisms, what are they? At the end of the day, they're just peer-to-peer agreements. So having parties be able to reach consensus and agreement on the state of a network without having an intermediary. So facilitating an agreement amongst participants to guarantee data consistency, and it's designed to incentivize good behavior in the network. So you obviously don't want a lot of bad actors overloading the network with false transactions. You want to have a system that decentivizes bad actors and incentivizes the good actors. And so real quick, to sort of highlight the issues with, is it gonna load? It's not, okay. Well, not a big deal because I can talk about this. So the Byzantine general video, it's just an animation highlighting the problem of the Byzantine generals problem. So you can imagine this. Let's say you five right there. Imagine if you were a little bit more like spread out, like you couldn't talk to each other, like you were miles apart, okay? And this was a city in between all you guys. And you guys needed to decide whether or not to attack the city. You guys reach consensus on a general rule of majority goes. So whatever the majority rule is from the generals, like whatever the majority vote is, that's what you guys will do. So if 3 out of 5 say attack, you'll attack. If 3 out of 5 say don't attack, then you won't attack. But the issue is you guys are all far away, so you guys are distributed away from each other. And you can't use light flares because then the town will see you. So what do? You send messengers, obviously, right? So maybe Sullivan will send a messenger to myself or to Dane saying attack, but how do you know that he got that message? What do?
He sends someone back.
So you got to send someone back to validate that yes, he got the message to attack. But what if that person going back gets intercepted and they send back a fake person to say, oh yes, he got the message to attack? So it sort of just highlights this issue of how do you reach consensus in a distributed, somewhat, I guess in that case it's not necessarily anonymous, but how do you reach consensus when you're not directly with the people? Like it's spread out, a decentralized network. How do you reach consensus amongst that? And so, yeah, so then from there we just dive into various consensus mechanisms. What that really highlights is the consensus mechanism of practical Byzantine fault tolerance, which is really just majority goes. It's the concept of that. Proof of work which is what Bitcoin and Ethereum are based off of. This expands on that a little bit more and integrates the cryptographic hash functions that we were talking about earlier to really root data validity and data integrity by sort of validating the contents of the block by hashing it and comparing the hash value comparing the hash you get to the hash value of the block we'll talk about that a little bit more, and that's what the activity is about today. And then there's also proof of stake, a spin-off of proof of work that was proposed to get rid of some of the issues of proof of work, which we'll talk about after the exercise. So, right now though, this is pretty cool actually, because we have just the right amount of people, but we're going to be doing what we call the blockchain game. No! Why is this? Okay. So, who's ready? Let's get into it. So, and I made this presentation to be standalone so that we